Hey everyone, welcome back. And today we're diving into something that's all around you and you probably never noticed. Why doesn't a hanging bridge collapse? Why does a zipline cable sag the way it does? And how does this big crane support its weight without falling onto its front? The answer? Static equilibrium. And today, we're not just defining it, we're proving it. An object is in static equilibrium when two conditions are met. The sum of all forces is equal to 0, and the sum of all torques is also equal to 0. To put it simply, nothing moves, nothing rotates, because every force has a partner that cancels it out. Physics is basically nature's way of keeping things drama-free. Alright, so that's the theory. But here's the fun part. We actually tested it. Setup 1. One hanging mass, one string, and one angle. Simple, right? Here's what we found. The heavier the mass, the higher the tension, every single time. That's not a coincidence. That's physics doing its job. The vertical component of tension is what fights gravity and keeps everything still. Now, did our numbers match perfectly? No. We had an average percent error of about 30.54%. But before you panic, let's talk about why. These are real-world gremlins that sneak into every experiment. But here's the key takeaway. Despite the error, the trend held. Tension still rose with weight. The physics still worked. That's what matters.
Set up 2. Now, this is where it gets interesting.
We upgraded a two-sided system, think zipline, with both angles equal at 31 degrees. Now, instead of one string doing all the work, both sides share the load equally. The equation changes to T is equal to 2T sine theta y.
And guess what? Our measured values were much closer to predicted this time. Why? Because symmetry is powerful. Equal angles means equal tension distribution, and the system is balanced more efficiently.
It's like carrying a heavy box. You always want someone on the other side. Here's the one thing that I want you to walk away with. Angle matters more than you think. The shallower the angle, the higher the tension, even for the same weight. That's why power lines and suspension cables are designed with very specific angles. Get the angle wrong and the tension skyrockets. So there you have it. Forces, angles, and tension, all working together in perfect balance. Our experiment confirmed what the equations predicted. Static equilibrium is real, it's measurable, and it's everywhere. Thanks for watching, and remember, the world isn't falling apart, it's just in equilibrium.